The last video was the basic introduction to functions calling, and there are two aspects that we wanted to improve in this new video. The first one was how can we retrieve dynamically the correct function based on its name. We didn't want to keep maintaining a big if statement if we keep adding more tools. And secondly, we also didn't want to execute the same piece of code manually several times until we get the final response from the LLM. Ideally, we would like the LLM to operate in a loop until it can produce the final answer. So these are the two things that we'll try to tackle in this video, starting with this if statement. I just added here what you need to execute if you start from this section, if you didn't do the beginning of the notebook yet. And here, this is what we wrote last time, the toolbox. I will show you one approach, how you could replace this if statement. So just as a reminder, in the toolbox, we've got two dictionaries that contain the description of the two functions that we want to expose to the LLM. So there was one which is called adder and one which is called multiplier. So you can add two numbers together or you can multiply them. So to replace this if statement, one option could be to use the globals function in Python that returns as a dictionary all the global objects that you have in your current session. So if I execute this one, you can see that this is a dictionary with these curly brackets, and you can see the different keys, which are the different objects in the current session. And as this is a dictionary, it means that if you've got the name of the function, and in the previous example, we had a variable underscore name that contained the name of the function to execute from the tool call. So if you've got this name, you can provide it just to query from your dictionary. And I run this, and you see that based on the name of a function, it can find the function in my active Python session. So that's one way that you can do it. And now that this part returns your entire function, your function object, so you can just provide some parameters and execute it as you are used to. So if I provide a x number, let's say 8, and a y number, let's say 9, so I get directly the result of the function execution, 17. The only drawback with this method is that if you are dealing with different modules, so some that you wrote yourself, some that you import, it could be quite easy to get some name conflicts. So that's the only drawback. Otherwise, that's quite easy to implement. This is a one-liner and you can replace an entire if statement block. The other option, and that's the one I used in this notebook, is that within this toolbox, I added two new lines, one for each tool, and I named it func. This could be whatever you want, just a key name which is not used already. And you see that under the name, so the name of the function here is a string, adder, and here I don't have the double quotes because I don't provide the string this time, but I provide the function. So by doing so, I have in this dictionary both the name of the function and the function. So it will be very easy. If I have the name, I can find the corresponding function. And I did here the same with multiplier. So there is the name multiplier. And if you give it to me, I can return in exchange the corresponding function. This is how I can build this tools registry dynamically. So I produce a new dictionary where each key is a function name and each value is the corresponding function. Let's try to execute it. And you see here that indeed I've got two tools in my toolbox. So I've got two keys in the dictionary, adder and multiplier. These are strings here, and then their corresponding values are the corresponding functions. So here there is the function adder, and there is here for multiplier, of course, the function multiplier. If you are not used to this dictionary comprehension notation, this one-liner, this is exactly the same as writing a small loop here, where you are going through each tool in your toolbox, and for each entry, you are just updating another dictionary. So as we said, the key in the new dictionary will be the string, the function name, and the corresponding value will be the function. So Maybe you are more comfortable with this notation. Just keep in mind this is exactly the same. It depends on your preferences. Now that we have improved that part, we want to write the loop. And if you remember in the previous notebook, each time we reinvoked the model, we had to check if we had some tool calls. If yes, we will need to process them. If not, we could display the final answer. And we had to run this several times manually. So the easiest way to deal with this is to create a function in which you implement all these loops. So you really just send the question to the LLM, and that was represented here by this user query parameter, which is just a string. And it will keep looping through all these messages, tool calls, until it can produce the final answer. So in addition to this query, I also provide here the current memory variable with the list of all the messages so far. And when the function returns a value, this will be the updated memory with all the messages that I append. So you could also implement a global variable instead, so you don't need to provide your memory. I just prefer this approach, but it's up to you. At the beginning of the function, I provide the model name. I just save it in a variable because I need to use it several times in the function. So like this, I don't repeat myself, and if I want to change the model, I just change it in one place. After that, I'm just checking if the memory list is empty or not. And if this is empty, it means we are starting a new conversation. And in that case, I want to add a system message. So my system prompt at the very beginning of the conversation. If you provide to the function a memory list that already contains some message, it will skip this. It will assume that if you wanted to add the system message at the beginning, you already did so. After that, we can create a user message based on the user query that was passed to the function. So exactly what we have done in every situation so far. So memory.append, we create a user message and we provide the text of the question from the user. What is new now is to make sure that we are not stuck in an infinite loop or that we don't run too many times if the model is not able to produce the answer, is that we introduce here this concept of maximum recursion. So each time we add the tool messages, we need to reinvoke the model so it can process the new history list. And if it does it more than 10 times, then I want to break out of the loop because I assume that if it still didn't manage to answer my question, it's probably not able to do so. So this is quite a safe practice if you don't want to incur too much cost or to wait too long time when apparently the LLM is not able to produce a good answer with the context and the tools that you provided. So here I just define maximum 10, and then I've got a variable here to track the number of iterations that I've had so far, and this is what we use here in this main loop. So keep looping until you are reaching this maximum recursion. The first step, of course, is to request completion. So far in the memory, we've got the system prompt and the user message, so we need to request a first completion with the model that we saved, Mistral small, the memory so far that has these two messages, the system prompt and the user message, and of course we provide our tools as we did in the previous video. After that, I can extract from this response the assistant message, and I can directly append it to the memory so I do not forget. Something which is new is I'm checking here if there are some tool calls in this message, and if it's not the case, we can already exit the function, because if there are no tool calls, it's most probably that there is some content provided, and in that case, this is the final answer from the LLM. We don't need to keep looping in this function. Then execute tools. That's what we did in the previous video. So for each tool call that we had in the message, we need to extract the name of the function, the arguments, the ID, and also the arguments and the ID. After that, what's new is that we don't have the if statement anymore. So as we said, we can use this tools registry where we provide the name of the function that we extracted from the tool call and the arguments also that we extracted from the tool call. So now instead of a big if statement block, we can have this one-liner that execute the correct function with the correct arguments, and the result of this function execution is saved in this variable output, which we can pass to the LLM via the memory. So we create a tool message in which we save the outcome of the output of the function. The tool call ID is mandatory, so it knows how to match the original tool call to the tool message that we'll create now. And optionally, you can provide the name of the function that you ran, but it's really optional. So we append this to the memory. We increase the number of iterations, and we can go back to the beginning of the loop where we need to reinvoke the model. So if you remember from the previous video, each time you add all the tool messages to your memory, you need to reinvoke the model so it can assess what it has so far and if it is now able to produce the final answer or if it needs to run more tool calls. So once again, after we invoke, we are appending the message in the memory and we are checking. So if this is the final answer, if we don't have tool calls, we can now exit the function. If not, if it needs to execute again some tool calls, if there are some follow-up questions in the prompt, then it can again process all these tool calls, increase the iteration, go back to the beginning of the loop and check. And it will do so until there are no tool calls or until we reach the maximum recursion. To be fair, it's quite easy at the beginning to mess up the things, to forget to add the messages at the right time, or to forget something in the loop. So you may make a couple of errors as I did, and you just need to keep improving your loop until you nail the logic. Something to keep in mind is that the order in which you add the messages can be important. For example, you'll get an error if you add a tool message right after a user message. So tool message can be only after another tool message or after an assistant message. So there are a few rules like this to be careful about, and you will come across some errors if you do not respect these rules. The only thing I didn't mention so far is that if we reach this maximum number of recursion, so we exit this main loop and we are getting in this part of the function. And I wrote as a comment that if you hit this maximum recursion, it means that the last message we added to the memory was a tool message. And in that case, we need to reinvoke the model anyway, so the LLM can produce the final answer based on all the messages that it has. And notice here, to make sure that I'm not stuck in another loop, I do not provide the tools. So this is a basic completion without any tools, because I don't want it to try again to run some tools. I know that it's not able to produce anything so far because it reached this maximum recursion. And then we can append to the memory and return the memory to the user. So let's give it a try. I create a memory variable, which is an empty list at the beginning because I start a new conversation. I provide a new prompt to the LLM, and then I just run this function that I created, invoke. My user query, on purpose, I'm asking several questions, two that it can run in parallel. In the first message, 7 plus 9, 5 plus 32. So these are two separate questions. And finally, once it receives the result of this and the result of this, it can multiply these two numbers together. So this is to make sure that after it runs two separate tool calls, it can still re-enter the loop and it can run a different one. And the result of this function will override the memory with the updated memory. So I try to execute and see how it goes. Took less than 2 seconds, and we can now inspect the memory to see what it did. So the first message is the system message, as expected, and then the question from myself. So how much is 7 plus 9, 5 plus 32, and multiply the two numbers together. After that, we've got the first assistant message, and it was also expected that we don't have any content because it was very likely it would want to run some tools. So here we see some tool calls. So the first one, it wants to run adder. X is 7, Y is 9. And then if we scroll to the right, we see that the second tool call, it's still the same function, adder, but this time x is 5 and y is 32. Within our loop, we executed these different functions and we provided the result back to the memory. So here we see a tool message where the result is 16, so the result of 7 plus 9, and the second one 37, which was 5 plus 32. After that, we reinvoke the LLM and you see another assistant message that has no content because it realized that even after it receives these two results, it is not enough to produce the final answer because I'm also asking to multiply these two numbers together. So it re-enters the loop, realizes that still there's no content, so it wants to run an additional tool and provides me the tool call here. So this time the tool call is for a different function. This is for the multiplier function where x is 16, which was the result here provided in this tool message. So it used the context of these tool messages to be able to run an additional function. And then y37, which was the second tool message. After that, our loop produced the result, 592, and now when we reinvoke the LLM, it has enough context to answer the question, and it can now tell us that 7 plus 9 is 16, 5 plus 32 is 37, and if you multiply the two together, it gives you 592. So this was really everything I could show you for the basic tool execution and how to produce it in a loop. We will see that actually this pattern that you prompt LLM and you are operating in a loop until it can produce the answer is a so-called React agent, like this, reasoning and action. And of course, there are some packages that can simplify this process, so you don't need to write everything from scratch. It's just good as a tutorial to understand how it works. So then you get the intuition, how it works, and you know also how to debug the things in the future. So there are two things I would like to see in future videos with you. The first one is how this process is simplified by Mistral. They've got different APIs, conversation, and agents that simplify some of these, and you can also get access to some pre-built tools. And also then we could start working with LangChain that also has a React agent, which is extremely easy to set up, and you will actually better understand everything that you get for free with LangChain after you have implemented the loop yourself manually. So I'll let you practice a bit and I will see you in the next video. Bye bye.